Namaste. Welcome to our YouTube channel. So today we are going to discuss question number 5 from PSB 2023. Where question says that we have a sample of size n from this particular distribution, which is nothing but shifted exponential with parameter theta. We have this particular functional form psi theta, and we have theta n hat, which is nothing but minimum of our sample. And we have the bias to estimate psi theta with respect to psi theta n hat. And these are the two statements that we need to prove or justify. So let us move forward to the basic concepts that we are going to use. One is, what is the definition of bias? It is nothing but expectation of the estimator minus the parameter that we are estimating. Then a simple consideration, that is, if x follows a shifted exponential theta, which is nothing but this distribution, and x minus theta is exponential 1, then x order 1 minus theta will follow exponential with mean 1 by n. And distribution is this. This is the density of exponential with mean 1 by n. So how can we use this in our problem? So in our problem, theta n hat is the minimum of x1, x2, xn. So following this particular statement, we have that theta n hat minus theta will follow exponential with mean 1 by n, and we'll have the density this. Alright. So let us move forward. We will do a basic simplification of the problem, where we will try to simplify this functional form. We don't want this integral here because we cannot move forward with this integration everywhere. We want a simplified form, which we can actually use, break, and prove something using it. Okay? So this is what we can write from this. What is this? This is the indicator function. It is 1 when x is greater than or equal to theta, and it is 0 otherwise. That is coming directly from the PDF of the shifted exponential. That is already given in our problem. So this is nothing but this, because it is taking the range from maximum of 1 to theta, because below it the function will be 0, right? Because of this particular indicator. And following it, this is the simple form of our function, psi theta. So this is the simplification. Now from here, we get that psi theta and hat is this. Just putting theta and hat in place of theta. Alright. So next we move forward to the part A of the problem. First, we consider that theta is greater than or equal to 1. So for theta greater than or equal to 1, we have psi theta is equal to 1. Simple. And what is the expectation of psi theta and hat? So in place of theta and hat, we just adjust it with a minus theta. We multiply this part with e to the power minus theta, and we divide this whole part by e to the power minus theta. So that is the basic adjustment with the term of this minus theta here and here as well. Right? And we know that theta and hat minus theta has a particular distribution. We have already seen it. So let us put t in place of this. And we know the distribution of t. We know the density of t as well. So let us put it in the density format, in the definition of expectation. And we can integrate this out. It is simple, and we are getting 1. Okay? So from this 2, what we get is the bias for theta greater than or equal to 1 is 0 always. So the first part of the part A is proved. Now what is the second part of part A? It is for theta less than 1. So let us go towards that. If theta is less than 1, what is our psi theta? It is e to the power minus 1 minus theta. That is quite apparent. But what is the expectation? So the calculation will be a bit difficult in this place. Up to this, it is similar. We are adjusting with theta, putting t in place of theta and hat minus theta. We know the distribution of t. But then, at this step, we need to break the range, because this maximum thing will be different at these two ranges. So that is why we are breaking it out. So what is the integration of this particular form, and what is this? We can integrate it, right? It is quite simple. So this is what we are getting. For this, e to the power minus n into 1 minus theta is the integration that we are getting. And this part, we can adjust it like this. How we are actually adjusting it? We are taking out the constant part outside, and we are adjusting this in minus 1 factor. Why? Because you can see that this is nothing but the PDF of an exponential distribution with parameter or rate n minus 1. So this is nothing but a form of a CDF of exponential, and we know what is the form of a CDF. That is what we are putting here, and this is here as it is. So this is the final form of the expectation. Okay? And then we do quite a bit of tweak to bring a kind of inequality so that we can actually show that the bias is greater than 0. So what is inequality? It is that this part is less than this part. That is why the whole thing will be greater than this whole thing. And this final step is nothing but e to the power minus 1 minus theta, which is same as this. So we get that expectation is greater than this, and from both of this, we get that bias will be greater than 0 for every theta less than 1. So yes, this second part of part A is proved. But one thing that you must notice is that this is the form of the expectation. So in the part B, for calculating the limiting value of the bias, we will be needing this particular expression to calculate the bias, because this is just an inequality, but the actual form is this. So let us move forward. In part B, we know that this is the bias, okay? So if n tends to infinity, then what is this? N by n minus 1, it definitely tends to 1. And this whole thing will tend to e to the power minus 1 minus theta, which is same as this third term. So this 2 will cancel out. And what about this? So this is what we will elaborate a bit. So since e is always lying between 2 and 3, and 1 by e is less than 1, so we have 1 by e to the power 1 minus theta also less than 1, because theta is greater than or equal to 1. Now if this quantity is less than 1, when we raise this quantity to the power of n, that will definitely tend to 0 when n tends to infinity, right? So that is how we can get that this particular term will tend to 0, because 1 by n minus 1 will also tend to 0 as n tends to infinity. So yeah, simple. That is how we get that the bias will tend to 0 as n tends to infinity. So yeah, it is proved now. So if you like this video, share something you have with someone who needs. Hare Krishna.